Hi guys, so today we'll be discussing about a data analysis software, that is SPSS, and the technique that we'll be talking about is exploratory factor analysis. So this technique is generally used using the quantitative data when you have collected the data using 7-point, 5-point, 9-point, or 11-point Likert scale. Now, why EFA is used? Because when we are moving on to conducting the confirmatory factor analysis, we should have a clean matrix. Now, you will be seeing it in the coming part of the video, that what I'm talking about. For example, what happens that I have chosen some of the employees and I've collected the data from the IT employees. So this data represents the questionnaire filled by the IT employees. Okay. So what happens that I actually had 20, 30 questions and I had a pile of questions and I sent them the questionnaire. They filled it and I got the filled questionnaire back. Now they did not know about these factors. They only knew the question. So, but I knew that I had 6 items in training and development, 4 in CSR, corporate social responsibility, 3 in work-life balance, 4 in compensation benefits CB, and 5 in HWA, healthy working atmosphere. But they did not know about these factors. So I have to see that if all the items of the healthy work atmosphere are falling under a single construct. So this is what EFA is used for. So how to conduct exploratory factor analysis? You have to go to analyze, you have to go to dimension reduction, then factor. Now, I'll be selecting all these items. These items are actually the questions, but in SPSS term, we use them as items. I'll be selecting them in one go and putting into the variables section. Then descriptives, if you want mean, median, mode, standard deviation, these kind of descriptives you need. We definitely need KMO. Then extraction. Okay, this is fine. Principal component will be using eigenvalue more than one. Rotation, there are different types of rotation and like Varimax, Oblimin, Quadrimax, Ecomax, Promax, but I'll be using Varimax for my data. Then going to the scores, I'll be just leaving it like that. Then in options, I'll be suppressing the small coefficients 0.4 in order to get the clean matrix. I think 0.4 is standard and it is an ideal number that you can use for suppressing small coefficients. Then I'll be clicking on OK. Now you see that the KMO is more than 0.5. It is generally said it should be more than 0.7, which is considered to be better. So as it is more than 0.7, so our data is fine with the degrees of freedom 253. Now coming to the total variance explained, it is more than 50%, that is 65%, means all of my 5 factors are explaining 65% of the variance in my data. So this is also pretty good. It should be more than it should be more than 50%. Next is the rotated component matrix that we have to see. Now you can see how clean my matrix is. All the items of training and development are falling under second factor. CSR, all the 4 items. WLB, all the 3 items. Compensation and benefits, all the 4 items. And healthy working atmosphere, all the 6 items. So this type of component matrix we need. But sometimes what happens that, for example, it is having 2 loadings. It is falling under TD, which means that the question was almost the same and they took it as the same question, the respondents, the IT employees. So if the difference, for example, if it would have been 0.5, then if the difference is more than 0.2, then you can ignore it and you can go for the higher loading like 0.8. But if it is more than, if it is less than 0.2, like for example, if the loading would have been 0.7 here, this space, then sometimes you have to drop this item. Why? Because it can create problem while you are conducting confirmatory factor analysis, as you can have problem in your indices. You can, when you are going for CFI, GFI, RMR, SMR, RMSCA, these type of indices which you will be learning in CFA, so that can create a problem. So here, if you are, because why first step is important, because when first step is fine, then the second step will also be fine. So when you are correcting all the mistakes in your first step, that is EFA, then your CFA will be good and all your data will be good. And whenever you are going for regression, you're going for correlation, your data is authentic and you can then give your findings based on your data. So data analysis is really important and you should get the right data. So this is a rotated component matrix which is really clean. And two things that you have to remember, that when you are getting multiple loadings, if it is more than 0.2, ignore it and delete it and go for the higher one. If it is less than 0.2, then you can, according to the literature, if literature says, then you can remove it, or you can also give your own suggestions for that. So this is the rotated component matrix, and this is the EFA that you can use before going for CFA. It is a common practice, and I also, as a researcher, use it. I first conduct EFA, and then I go for CFA for MOs. Thank you. We'll be coming with more videos on SPSS, exploratory factor analysis, confirmatory factor analysis, and also the type of rotation that I used, Paramex, and why I used it. I'll be sharing in my next video. Take care. Bye.